liquid nitrogen. Are you guys ready to check this out? You guys might have to look really, really closely because this liquid nitrogen is very, very cool. Here we go. Yeah. Very, very crazy stuff. Yeah. Now, do you guys see that liquid nitrogen? Yeah? What's it doing right now? Is it boiling? Is this stuff really, really hot or really, really cold? It's really cold. Liquid nitrogen has a boiling point of -322 degrees. That is pretty cold. It is possible. It's really, really cold. So at room temperature, it immediately starts to evaporate. And that's what you see going on right here. This stuff is getting bubbling and boiling over really, really quickly. How do we really know it's boiling? Maybe I'm just doing a magic trick. Maybe this is like a trick beaker or something like that. Well, I'm going to prove to you guys that it's boiling. When you guys put boiling water into a teapot, what usually happens? It whistles, yeah. So if I put this boiling liquid nitrogen in here, it should sound something like that, right? Yeah, I think so. What do you guys think? Yeah, it should. So let's see if we can make our teapot whistle with boiling liquid nitrogen. Here we go. Just like that. That's right. Do you guys know why it's whistling like that? Yeah, it's because of all the pressure being built up. Because when liquid nitrogen goes from a liquid state to a gas state, it immediately starts to get excited. All those gas molecules need much more room to move around. And that is why all that pressure builds up, and those gas molecules look for the easiest way they can to escape. And that is right through the little hole right there. And that is why it's whistling. You guys like that? All because of pressure. You guys can dance along too. Okay. Yeah. Really, really cool stuff. All because of pressure. Now, I'm going to save my liquid nitrogen because this stuff is really, really expensive and you can't really get it very often. Liquid nitrogen isn't a naturally occurring substance on Earth. Liquid nitrogen occurs naturally as a gas, so it's hard to get it in liquid form. And it's very, very expensive, and we like to conserve here at the Science Center. So I'm going to save this. I'm going to cap it off, and we're going to move on to a little demo. I don't think I sealed that very well. Let's try that again. There we go. This is just not working out for me. Okay. Alright, no more fooling around here. There we go. Now, we can move on to... You guys know why it's doing that? Yeah? Why is it doing that?
Because of the liquid.
Yeah, it's all because of pressure, just like that teapot. That's right. All that liquid is going from a liquid state to a gas state, and it looks for the easiest way it can to escape, and that is right through the core. Just like that. And that is why you can't get it without a yeah. Amazing stuff. Thank you so much, man. Thanks. Alright, well, obviously, we can't contain it with that little cork. So I'm going to pass this along to my beaker again, and we're going to try and put it into a smaller container and see if we can hold this stuff hostage for a little longer. I'm never going to give up. This is my favorite stuff, liquid nitrogen. So we're going to put it into my little container here. Hopefully, we can conserve this stuff, but I need something other than that rubber stopper. Can you guys think of anything else that's rubber and can like expand and stretch when like gas is added to it? Anything at all? A balloon? Yeah, a balloon might work. You guys want to see if we can get a balloon to work? I think that's a great idea. I think that'll solve all of our problems, and I just happen to have a balloon right here. So, why don't we try a balloon here? I think that'll work out just fine. So here we go. There we go. Never gonna give it up. Liquid nitrogen's mine to keep forever. We've figured it out, haven't we? We've solved this problem. Nothing's gonna go wrong here, right? You guys see that? Yeah. All that liquid nitrogen, yeah, see it? All that liquid nitrogen is still at the bottom, and it's all bubbling and going from liquid state to a gas state. This balloon is starting to expand and accommodate. Yeah. We all know that balloons never pop, so we figured out a way to safely contain this stuff, and this liquid nitrogen will be in here forever. All those that one, you guys see it? Yeah? I mean, pretty cool stuff. Yeah. You guys see it over here?
We made a good idea.
and it fills up the balloon. Why don't we take a look at what liquid nitrogen would do to a balloon that's already been inflated with some gas. So what I'm going to do is get this balloon to fit inside this hole. And how I'm going to do that is I'm going to inflate this balloon with my own gases. So I'm going to